Hello everyone. Today we're going to go over lesson 6.3, tests for parallelograms. Our objectives are to recognize the conditions that ensure a quadrilateral is a parallelogram, and we're going to prove that a set of points forms a parallelogram in the coordinate plane. So if a quadrilateral has opposite sides parallel, then it's a parallelogram. Guys, that's what it means to be a parallelogram. So kind of definition type there. If you can prove that opposite sides are parallel, both pairs of opposite sides are parallel, then you've got a parallelogram. Guys, other ways to check this, a couple of theorems, guys. If both pairs of opposite sides are congruent, then a quadrilateral is a parallelogram. Okay? So these are kind of reversals of yesterday, converses of yesterday. Okay? If opposite sides are congruent, then parallelogram. So if AD is congruent to BC, and the other pair of opposite sides, AB, congruent to DC, DC. Okay. If that's true, then quadrilateral A, B, C, D is a parallelogram. Kind of ran out of room there. All right. So, and then the same's true for the angles, guys. I think you guys could probably practice theorem 6.10 if both pairs of opposite angles are congruent. So A congruent to C, D to B, then it's a parallelogram. So kind of working backwards from yesterday. All right. Even here with diagonals. If the diagonals bisect each other, then it's a parallelogram. Okay? The one that is kind of different than anything we did yesterday is 6.12. Okay? This one just works on one pair of sides. If one pair of opposite sides is both parallel and congruent, then it's a parallelogram. So if you can show one side is congruent and also parallel, that's enough as well. Okay? So we're going to work on using those four conditions to show or to determine if quadrilaterals are parallelograms. Okay? Example 1. Determine whether it's a parallelogram and justify your answer. So we've got opposite sides. We've got one pair of opposite sides, FG. We've got that is congruent to JH. Okay? We don't really have enough information to say the other pair is opposite. The other pair of opposite sides is congruent, which would be using theorem 6.9. Okay. We don't have anything about angles, so we're not going to use theorem 6.10. We don't have anything about opposite angles. 6.11 is about diagonals. We don't have diagonals drawn, so I guess what we're going to need to do is try to use 6.12. We know that one pair is congruent. Can we show that FG and JH are parallel? Okay. Let's think back to semester 1. Here we have a line that goes through two transversals. Guys, these angles that would be considered consecutive angles, okay, are supplementary. They add to 180. That means these lines are parallel. These sides are, in fact, parallel. So, FG is parallel to JH. Okay, that's by consecutive interior angles being supplementary. And so, yes, this is a parallelogram. Our justification is theorem 6.12. One pair congruent, one pair opposites congruent and parallel. 1A, we've got two pairs of opposite sides congruent. That's theorem 6.9. We've got one pair opposites congruent. We've got one pair sides congruent. That is none of our theorems, so there's not enough info. So a no. Not enough info. Okay? We would either have to have two pairs opposite angles congruent, two pairs opposite sides congruent. And unlike problem 1b, we don't have consecutive interior angles. We don't have consecutive angles that we could say, hey, these angles are supplementary. We don't have that, so not enough information here. Okay. Example 3 here, we're going to use parallelograms in algebra to find values. Okay. In this problem, if fk is 3x minus 1, fk, 3x minus 1. Kg is 4y plus 3. Kg here. Jk, 6y minus 2. And kh, 2x plus 3. Okay. Find x and y so that it is a parallelogram. Guys, if this thing is going to be a parallelogram, the diagonals are going to have to bisect each other, meaning that Kg, back to my green, actually I'll go to my mouse here, this segment Kg right here, that's going to have to be parallel, and maybe I should use green, not parallel, sorry, congruent to Jk. And so the value of y that makes those congruent is, solve an equation. Subtract our 4y's. 3 equals 2y minus 2. Add 2. We got 5 equals 2y. Or y equals 5 divided by 2, 2.5. That's the value of y that would make it a parallelogram. We also need the value of x. Okay. This is a parallelogram. FK, KH, those two segments are congruent. Which allows us to use another equation. 3x minus 1 equals 2x plus 3. So x minus 1 equals 3. X equals 4. Those are the values of x and y that make this a parallelogram. Okay, diagonals would have to be bisected. Here, guys, opposite angles are going to have to be congruent. Both pairs of opposite angles. So you can set up your equation here. 7x equals 56. You're going to get x is 8. And then you can go 4y plus 4 equals 5y minus 26, which is going to give you y, I believe, is 30. Okay? Those would be the x and y values that work. 8, x is 8, y is 30. Just trying to do the arithmetic here. All right? So, guys, these are the ways to show, this is a summary of the ways to show a quadrilateral is a parallelogram. Our definition, and then our 4 theorems we just used. Okay. Last problem, our second objective was to be able to show that a set of points is a parallelogram in the coordinate plane. Okay, so here we have the set of points. K is at 2, 3, L, 8, 4. N, 7, negative 2. And N, 1, negative 3. You're going to have to kind of excuse my drawing on this board is pretty tough. So that's our points, K, L, M, and N. And we want to determine if this thing is a parallelogram. Okay? In a parallelogram, if we used the definition of a parallelogram, which was kind of the first thing we talked about, if we could show that opposite sides are parallel, then we know it's a parallelogram. Okay? In the coordinate plane, segments and lines would be parallel if they have the same slope. Segments, and this is something we talked about in first semester, segments are parallel if they have the same slope. Okay? And definition of a parallelogram, opposite sides are parallel. So, well, let's find the slope of KL. The slope of KL, rise over run, you go up 1 over 1, 2, 3, 4, 5, 6. Up 1 over 6. Well, is the slope of NM the same? Go up 1 over 1, 2, 3, 4, 5, 6. Just counting, guys. So the slopes of KL and NM are the same. So those segments must be parallel. Guys, do the same for KN. Okay, using rise over run again. Slope is rise 1, 2, 4, 5, 6, up 6 over 1. ML up 1, 2, 3, 4, 5, 6 over 1. Slope is 6 over 1. So ML and KN are also parallel. Yes. It's a parallelogram. So parallelogram. Use our symbol there. KLMN. Okay. So that was using the definition. That's probably the easiest way, using rise over run, or just slope in the coordinate plane. Easiest way to prove that a shape is a parallelogram, I think. Okay, that'll end our video, guys. This assignment does come from the textbook. Okay, I know many of you guys might not have brought that to class. I did say a lot of second semester stuff is going to come out of the textbook. So make sure you start bringing that if you didn't bring it. I have also put a screen capture from the textbook. Screen capture. And the Canvas module, so you guys can see that as well. So that'll be there. If you didn't bring your textbook and you want to work on your homework a little bit, that's there. Okay? Everyone have a wonderful weekend, and I'll see you all later.